Very good evening to all. Um, I welcome you all to the NPTEL online course certification on mass transfer operations. So this course has been offered in SWAYAM online portal, and I'd like to begin with this first dry week, that is week 0 dry run. This course has been offered by Professor Vishnu Pada Mandal, who is a professor in the Department of Chemical Engineering in the Indian Institute of Technology, Guwahati. And a little bit about myself. Uh, I am teaching assistant. So I will be your teaching assistant for the entire tenure of this course. That is from July to October or November. And my name is Rajput Shubham Ajay Kumar. I am PMRF Scholar, that is Prime Minister Research Fellow in the Department of Chemical Engineering at Indian Institute of Technology, Madras. So I will be your teaching assistant for the entire tenure of this course on NPTEL, and we will be having these live interactions every weekend, that is on Saturday at 3 to 4 p.m. for 1 hour, that is on every weekend. So we'd like to begin with the course first of all. So this is Mass Transfer Operation 1. This is a basic fundamental course for the undergrads in the chemical engineering department, and this course can also be taken by the mechanical engineers and the engineers from the various different fields in order to get trained out from the various aspects of mass transfer. But this course is specifically for the chemical engineering undergrads as well as for the mechanical engineering. But specifically teaching will be helpful more to chemical engineers plus mechanical engineers also, because involves the aspects of both chemical and mechanical modeling simulations also. So this is the basic course, that is mass transfer operations 1, and we'll begin with the week 0, that is a dry run. So we'll be looking out what is the basics of mass transfer, what is mass transfer, what are lots of mass transfer, and we'll solve in some tutorial questions just like basics of the tutorial questions, so that by next week we can start the actual solutions, assignment problems, and looking after various concepts of the mass transfer as soon as this week process. So let's begin with the week 0 dry run. So the outline for this week 0 dry run is somewhat like that, because this is the first week, that is a week 0. So I would like to begin what is mass transfer. The second is what are the laws of mass transfer, and some of the tutorial problems, just like the basic concepts that will cover the basics of the mass transfer, just like for the week 0 dry run. Okay. So first of all, what is mass transfer actually? There is a mass transfer operation. So there is some operation happening and a transfer is happening. Similar to the heat transfer operations, where is a transfer of heat due to the temperature gradient. In mass transfer, there is a transfer of mass between the across the membrane or the boundary you can consider. So here, if you can see, there is a boundary. So this is what we call as a boundary, right, or a membrane. Boundary or membrane. Okay. So if you can see, if the here I have shown that two different molecules. We consider A as one molecule and B as second molecule. So, and if I place a membrane in between, so these two molecules will be separated by a membrane. So there will be no transfer of mass between them. So what I will do, if I separate this membrane, or if I remove this membrane from here, what will happen? These two molecules will try to combine. That is, try to combine in the sense they will try to equilibrate each other, and this equilibrium happens due to the change or the difference in the concentration gradient, or in the sense like in a heat transfer, the change happens due to change in the temperature gradient. Here in mass transfer, the transfer happens because of the concentration gradient or the pressure gradient, and many more. So this is what is happening here, that is because of A and B are compounds are not equilibrated because they are separated by a membrane. If I remove the membrane or this boundary from here, what they will do, they will try to equilibrate, and A and B will mix up together, and the transfer of mass usually occurs from the higher concentration to the lower concentration. So this is what happening here, that both are, if I remove this membrane, both red and the green will combine with each other, and this equilibration will happen until the concentration becomes equal. That is, higher to lower equilibrates each other. That is, the concentration of A and B becomes equal in the entire box. Okay, so this is what the basics of the mass transfer operation, and it happens usually to change in the concentration gradient, and mass transfer usually happens from the higher concentration to the lower concentration. Similarly, in the heat transfer, like heat transfer happens from the higher temperature to the low temperature. It's a flow of heat. Similarly, here what you're talking about is the transfer of mass, that is from higher concentration, molar concentration, to the lower molar concentration. Okay, so this is what the basic mass transfer talks about. There are many more definitions for the mass transfer, but the basic term what we use is a change in the concentration gradient, and it happens due to the this concentration difference in between the two molecules, and it flows, that is mass transfer happens from the region of higher concentration to a region of lower concentration. So now, as we know, there are laws of heat transfer, like first law of heat transfer, second law, third law, fourth law. Similarly, there are laws of mass transfer also. So we'll begin with the first law. What are laws of, sorry, just 1 minute. Laws of mass transfer. So there are two different laws. There is fixed first law and fixed second law. For this week zero dry run, we'll just listen to what is fixed first law of diffusion. So this term diffusion usually means about the transfer of molecules from one phase to another phase in try to equilibrate each other. This is the region of higher concentration to the region of low concentration. If I say two different molecules A and B and there is a boundary between them, so the A, if I remove this boundary, A molecules will try to move from region of higher concentration. That is, if suppose A is having a high concentration and B is having low concentration, so if I remove the boundary of the membrane, the diffusion of A molecules into the B molecules happens until the concentration of both becomes same, that is they equilibrate. So this is what is termed as a diffusion. So what is fixed first law of diffusion? If I write fixed first law of diffusion in terms of mathematical terms, it will be J of is equal to minus dAB del CA by del Z. So this is the basics first law of diffusion. Now I will try to say what is this equation terms about. So if you see this term, that is J, is known as a flux. So the flux of A in respect to B, that is directly proportional to the change in the concentration gradient. So del CA by del Z is the change in the concentration gradient in the Z direction of molecule A. Of molecule A in Z direction. Okay, so this is what is called as the concentration gradient. Now minus dAB. First I will talk about what is dAB. So dAB is the diffusivity of A with respect to B. Diffusivity of, you can say species also. Species A with respect to B. Now this negative sign is also there. So what this negative sign means? So as I said that the diffusion occurs from a region of higher concentration to the region of lower concentration. So diffusion usually happens in the region of higher to lower. So that is why negative sign is accompanies due to the flow from higher region to lower region. Flow from a region of high concentration to low concentration. So this is what basically the fixed first law defines. This is a diffusivity of A with respect to B happens from a region of higher to lower and is directly proportional to the concentration gradient, that is del CA by del Z. So this whole term corresponds to the flux, that is flux of species A with respect to B. So this is what the basics of mass transfer and what is a fixed first law of diffusion talks about. So now we will see some of the tutorial problems just like basics in order to solve just what we have just seen right now. What is mass transfer, what is fixed first law, and what should happen in that case. Fixed second law we will see in the week first actual assignments problem. So this is just like to try to say what are the basics of mass transfer, and that's all. So you can see this first question. So it turns about an insulator should have a low thermal conductivity, high thermal conductivity, low resistance to heat flow, and high porous. So just 1 minute. So if you can see an insulator, so a conductor, you know that it should have a conductive property. Similar to an insulator, it should have insulating properties. So it should have a low thermal conductivity because an insulator should not conduct anything. So the basic answer for this is the low thermal conductivity. Because for an insulator, you can define it should not not conductive. Okay, so the basic, if you consider non-conductive as an insulator, the only equation is that the low thermal conductivity. Okay, so this is the just the thing that you need to remember. What are insulators, what are conductors, what are capacitors? So these are just the terms that will come in the later term of the course as soon as we proceed through the entire tenure of the course. So suppose the similar term in an adiabatic process. So you might have heard of this in the same the heat transfer also similar. There is a mass transfer process in adiabatic also. Adiabatic also occurs in a mass transfer. So in adiabatic, so you might have heard of the term Q, that is Q is equal to heat transfer. We define Q as heat transfer. Okay, so if we consider Q as a heat transfer in adiabatic process, we say that the heat transfer is zero or temperature change is zero, work done is a path function, and enthalpy remains constant. So you can clearly pointed out that this two option has not been related to any one of the adiabatic process, because work done is a path function is separate thing, and enthalpy remains constant is another separate thing. But the only two things that you can relate is heat transfer is zero or the temperature change is zero. So as we can say that in adiabatic process the heat transfer Q is zero, Q equal to zero in adiabatic process. So this is a direct term in you might have heard during this heat transfer process, or if you're not heard, you can go through the definitions and all the things, because I'm not covering all the definitions, everything. What you'll be doing is that you'll be solving the assignments and the tutorial problems and some of the basic concepts prior to that solving the problem, so that it can help you out guys to solve all the problems in one time. So the best correct answer for this is heat transfer is zero. So we'll go to the next question and see what is that. So this is another one of the good questions that are taken from the assignments. So what it does is say is that rate determining step in a chemical reaction consisting of a number of steps in series is the dash step. So the rate determining step, if you consider minus of RAV, you might have heard what is the rate of reaction A with respect to B. That is somewhat like I'm considering like in CR if you have seen. So let's not discuss that here, but you might have heard of this term rate determining step. So in every process, suppose there are four different steps, chemical reactions are occurring. If you can see, A plus B gives C, C gives D plus E, and E gives F. So if you consider this is the main step, this is the slowest step, and this is the fastest step. So if I consider this is at main and slowest, this is the if you consider initiation propagation, that is on a different set of terms. So what I consider this is the main step and the slowest step, because our main product is here. If you consider this as a main product, E as a main, D as a main product, and this step is the slowest. So the rate determining step is a step which is happening in a number of series. So if you can say these steps are occurring in series, and if I want to determine the rate determining steps, the rate determining is a step which occurs as a slowest step. So the correct answer for this is B, because the step which is occurring in a chemical reaction in number of series, compiling of all the reactions, that is the slowest step in all the chemical reactions. So another questions. So which of the following statement is correct? So diffusivity decreases with increase in temperature, diffusivity increases with increase in the molecular weight, diffusivity increases with the size of the individual molecule, and D, that is none of this. So like during the beginning of the session we discussed what is the fixed first law of diffusion and what is diffusivity. So we have given that is J, that is fixed first law of diffusion is there minus DAB del CA by del Z. Okay, so this is first law. Okay, now if you consider the Floyd and if diffusivity is related to this, that is minus dB is the diffusivity coefficient. Okay, so we can relate directly to three equations. So the diffusivity decreases with increase in temperature, diffusivity increases with increase in the molecular weight, and diffusivity increases with the increase in the size of the molecule. So if you can see this equation, there is none of the term which can relate the diffusivity with the given options. So what you can say is that none of the above. So if you remember what is fixed first law, you can directly solve out this equation. The question. So the last question for today is that, like I said, the laws of diffuse mass transfer. Then the first law is known as the fixed first law of diffusion, that is given by Ja equal to minus Dab del CA by del Z. So what the term DAB is term about? So it's the diffusion constant diffusivity of A respect to B, both A and B, diffusivity of B in mixture of A and B. So like I said, D of AB is diffusivity coefficient, like I previously written in the previous question also. So it is known as diffusivity coefficient. Similarly, it is known as the diffusivity of A, that is the species A with respect to B. So there are two different options that can consider as a diffusivity coefficient, diffusivity, that is both A and B. So these two are options that is correct, okay? That you can relate from this. This is A and this is B. So the correct answer is C, both A and B. Okay, so just the basics, what is mass transfer, loss of mass transfer, in what we have seen the fixed first law of diffusion. We have related fixed first law of diffusion with diffusivity coefficient and the concentration gradient, that is del C by del Z, and how this diffusivity coefficient can relate with respect to species A and B. And this is what we have for week 0 as a dry run. So from this week, what we'll do is that we'll try to see how to solve the assignments for the week 1, as well as I will show more and more concepts prior to the beginning of the solving of the assignments problem and many more. So this is what I have for today, and thank you for joining this online live interaction for the week 0 dry run. I'll meet you guys next week. Till then, goodbye. If you have any problems, please just post in the Swayam NPTEL portal regarding this feedback session. Everything, if you need any problems, have any problems related to any week 0 dry run, please let me know. You can drop a mail directly to me, or you can on post in the Swayam NPTEL online portal, and also you can give the feedback for this session. Thank you guys. Thank you so much for joining this session. We'll meet you this Saturday, that is on weekend Saturday, 3 to 4 p.m. for the live interaction for the week 1 session. Thank you guys.